Hey folks, I'm making a video right now for you regarding the third review of the problems for the test on exponential functions. I just wanted to go over the hardest problems. I'm not going to go over every problem, but I'll go over the hardest ones, or the ones that people said to me that they struggled with. So anyways, I'm hopeful that maybe this might be helpful to you. I'm going to go ahead and start with plugging into exponential formulas. I do not think this is the hardest type of problem on the test, but it is a word problem, and people said to me that they were concerned. I don't think it's that bad. Now, one of the things I'm thinking of removing all the problems that have an e in them that require you to use a logarithm. You'll notice this problem has an e in it, but there's no logarithm required for this problem. And I know you don't know that yet, but I'll show it to you. So anyways, here all you got to do is punch numbers into the calculator. So let's take a look and see what I mean. When you read through this word problem, all you really have to do is realize how these numbers relate to this formula. And there's probably a couple of other tricks, like converting from percent to decimal. So anyways, I'm not going to spend a lot of time on it. It's going to go pretty quick. But here it says a person places this amount into an account. Well, if they place it into an account, that must be the initial amount, which we're going to call P. Okay, and then the final amount that we're going to calculate must be V. That must be what we're trying to calculate, is the final amount. They give us 3.5%, which is the R. And they also give us the number of years that the money will be invested for, 7 years. That'll be the T. All we got to do is plug in the numbers and calculate. I don't even know if I'm going to write it out. Maybe real quick. Let's see here. Maybe I'll just write it out for you. Let me see if I can show you. Okay, I'm supposedly markers coming up here. And so the P is going to be 29,800. And I do not like this pen. Sorry about that, guys. Let me see if I can. I'll get it. I'll increase that thickness a little bit, make it look a little bit nicer. And then we'll multiply that times E, which is just a number, and then raise that to the power of R times T. Now, I have to admit, you can get the wrong answer here, so I'm going to show you some tricks. Let's see here. So 3.5%, you got to know that that is 0.035 as a decimal. So we'll do that. That's going to be 0.035. But the other thing is this, is that you got to be really careful. When I write this, what I like to do is I like to write it with parentheses around here. But if you put a closing parentheses there and then you put the time in, you will get the wrong answer on the calculator. So instead, I'm just going to go ahead and put a little dot here to indicate multiplication. And then I'm going to go ahead and put the 7 there. And then I'll close the parentheses. And by writing it that way, it's going to be harder to get the problem wrong. Let's go ahead and take a look at that in a calculator like one that you might borrow from me. Let's see here. I'm going to go ahead and clear my calculator. And let me see if I can go ahead and bring this in. So we got 29,800 and 0.035. Let me see if I can do this. 29,800. Oh, good. Okay, so there are some numbers there. Let's see here. Is there a way for me to get this? Oh, good. I can scrunch this down. Maybe I can fit both of these at the same time. Close. So we'll do 29,800 times, and then to get E, we hit second and the LN button, but it's not just E, it's E to the power of something. And the good news is we need to raise it to the power of something. So I'll go ahead and put in the 0.035, but do not put a closing parentheses. If you try to put the closing parentheses like this, and then you go and put the 7 into another set of parentheses, you will get the wrong answer. Let me go ahead and just hit enter to see what we get. So that's 216,000. Let's. By the way, well, we'll in a minute we'll go and see whether that works or not. Let me go ahead and try it again. So I'm going to do 29,800, and we'll do times, and we'll do second ln to get that E. and then times, it'll be to the power of 0.035. This time I'm not going to close the parentheses, and I'll put in a times, and I'll say 7, and now I'll close the parentheses and hit enter. And now I'm getting 38,000. You got to admit, 38,000 is very different from 216,000. Let's see if it says what they want us to round to. They want us to round to, do they tell us? Round to the nearest cent. Determine the amount of money to the nearest cent. So I'm going to go ahead and type in the number, and then we'll round. It'll be I think it's going to be 38,073. And then I'll give you a bunch of decimals, 0.115. Now, when it comes to dollars and cents are usually represented by just 2 decimal places. So it's either going to be 0.11 or because of that third digit, it'll be 0.12. So it'll be either 0.11 or 0.12. If this third digit is some number between 0 and 4, like 0 or 1 or 2 or 3 or 4, we're going to just leave that as an 11. But if that third digit is 5 or 6 or 7 or 8 or 9, we're going to round that to a 2. So it turns out that the third digit's a 5, so we're going to make that a 2. And then I'm going to go ahead and say a little prayer and then press submit. Here we go. And we got it right. Yay. So that's the process of taking the numbers from the word problem and plugging them in. And this is one reason why I think it's okay for me to leave problems with E in the test, as long as they don't involve a logarithm. This is just punching numbers into a calculator. Okay, let me take a look at the next problem. Okay, here's another word problem, and it's a little trickier because there is no formula given to you. But it's not that tricky. It doesn't involve a half. It doesn't involve halving. It doesn't involve doubling. And they didn't give us a formula with E. So it's going to fall into one of two categories. And I'm going to show you, when we show the solution, we can see that either you're going to do y equals a times 1 plus r to the power of x, or you're going to do y equals a times 1 minus r. And if you go through a few of these examples, I'm just going to go new problem, new problem, new problem. You'll see that whenever the problem involves growth, we do 1 plus r. So if it says grows, we do 1 plus r. I'm going to keep going. New problem. Finally, we get to one where it says the car depreciates, which means it lowers in value. We will say y equals a times 1 minus r raised to the power of x. And we'll just plug in the numbers. So let me go ahead and let's back up. Let's go show a question, and let's take a look at one that grows. So in this case, what we're going to do is we're going to use a formula. It's going to take just a second for my little pen to show up here. And because it's growth, we'll use the formula y equals a times 1 plus r over to the power of, in this case, because it's growing over years, over time, we'll say to the power of t. And then we just need to plug in the numbers. The a is the beginning amount. That's the population they have at the beginning, 4,000. They want to know what will it be after 13 years. So all we got to do is plug in the numbers. It's 4,000 times 1 plus whatever the decimal is of this, and we dang it, we just did that. You know what? Let's, just so I can be fair, let me erase what I just wrote if I can. Let's see here. Let's erase all this. Let's try another problem where we don't have the exact same decimal. That'd be a silly example, right? So let me get rid of the pen, and new problem, and that's a different percent. And here, actually, let's go to one with growth. Decays, that would also mean goes down. And I'm kind of curious, if we look at the solution, still just 1 minus r. So anyways, it goes down, is placed. How much will the account have? Okay, in this case, the money's growing. It doesn't say growing, but it does have an annual interest rate of 6%, and without any other information, it looks like it's going to go up. So again, we'll go ahead and let me go ahead and get my pen, and we'll use the growth formula. So y equals a times 1 plus r raised to the power of t, because they give us 19 years, and then we just put in the starting amount as a 4,700. By the way, In these problems, A is never the ending amount. Never. And Y is never the beginning amount. It's always the ending amount. Always. Okay, anyways. Times 1 plus R, which they're giving us 6%, so that'll be 0.06. And then raised to the power of t, and they tell us it's going to be in there for 19 years. And then you can go ahead and plug this in the calculator. And what we're trying to solve for here is y. So I'll circle y real quick. That's what we're trying to solve for. So that one's pretty straightforward. Let me go ahead and I wish there was a way just to clear this. Is there? I don't see it. So what if I exit drawing and then I'll go back into and make a new drawing. Let's do this. Exit drawing. Let's go ahead and look at a new problem, and we will find one where it goes down. This one decays. So let's take a look at what the decay would look like. It is going to be y equals a times 1. Oops, sorry about that. 1 times 1. This time minus, because it's decay. So it's the amount, from the beginning amount to the ending amount, we're going down. So the beginning amount will be bigger and the ending amount will be smaller. And we have time, 12 minutes, so I'll put that in as t right here. And again, we're being given the beginning amount. That'll be a. So that'll be 620 times 1 minus, convert that percent to decimal, 0.236. And raise it to the power of 12. Now, I will be honest with you. When you're doing more advanced math, if you go and take a financial math class, you may or may not be able to just use this number in your equation. It just depends on whether the unit matches. Okay, if they say that the element decays so much percent per minute, and then they ask you how much is remaining after so many minutes, then you're okay. Then you can just go put the 12 in there. And for purposes of my test, absolutely. They do want you to get the answer to the nearest tenth of a gram. And let's take a quick look at the solution and see exactly what that will be. So you get an answer like 24.519522. To go to the nearest tenth, it means we want this digit, the 5 digit. We either want to leave it at 5 or make it go up. And we'll look at the second digit to determine whether that first tens place will go up or not. Since this is just a 1, that will not go up, so we end up getting 24.5. All right, let me continue on. I'm going to go ahead and choose the next problem. Okay, this next let's take a look. So the next group of problems involve half-life and doubling. Doubling means multiply by 2. Now, even though there's no formula, you and I, when you were in class, we looked at the solutions in Delta Math, and what we discovered is they do tell us the formulas. If you are working on a problem that says something about half, you will use a formula like this, and I told you could write it down on your index card, and hopefully you have. And then all you got to do is plug in the numbers just like we did in the last problem. Let me just make sure that there's nothing weird that could go wrong when you're putting the numbers in the calculator. So let's go ahead and try to plug this in the calculator and just make sure that you guys are with me. So I'm going to go ahead and put the calculator on the screen. Hopefully you can see that. And then I'm going to type 37,000 and then times. And then we'll do, to make it easy, we could just put a 0.5 here. Then you wouldn't even need parentheses. So I'm just going to go ahead and say 0.5. And then to the power of. And to get the power of, I got to press this button that is below the pi key. And you would too. So I'll do the power of. Here's the tricky part. I got to do to the power of 4 over 6, okay? And if you can't do that in your brain, and some people can, if you can't do that in your brain and you want to type it in, you have to use parentheses. So I would put 4 divided by 6, and if you do not put the parentheses around the 4 divided by 6, you will get the wrong answer. Let's just to be safe, let's go. Let me see if I can go back. Can I am wondering how. I'm going to try hitting delete. Oh, thank God. Okay. Let's go back like this. Let's say that I don't put the parentheses and I just do 4 and then I say divided by 6. And then I hit enter. Let's look at the result, okay? Now I'm going to do 37,000. And by the way, when you're at home watching this video, please try this stuff for yourself. Watching videos does not make you an expert. I have watched many professional athletes, and I still cannot do what they do. So you must try it yourself. Anyways, let me go ahead and raise to the power of, and this time we're going to use the parentheses. So 4 divided by 6. And the answer that we get is now, instead of 385, we now get 23,000. You see the difference? And take a look down here and see what the actual answer is. It's closer to 23,000 than it is to 385. So make sure you make a note that if you're going to raise a bunch of stuff to as a power, you have to use parentheses around that bunch of stuff. I wonder why. Oh, they say in their instructions, round to the nearest $100. So if we look at this, it's 23,308. When we're rounding to the nearest 100, we don't even need to worry about the decimals. What we want to know is it going to be 23,300 or is it going to be 23,400? Okay, that's what we want to know. And I am hopeful that you are with me that 23,308 is closer to 23,300 than 23,400. Okay, I'm going to go ahead and leave that at that, and we'll go on to another problem. And once again, we have another kind of problem. This one involves compounding. It says solve for future value. And in this one, they don't give you the formula, but I did give you a formula, and I asked you to write it down and include it on your index card. And it says show solution. I'm sorry, I'm going to show you the solution. And when you guys are looking at the example problems, they'll show you what the formula looks like, and this is it. This should be on your index card. Now, if you are compounding monthly, then you need to know what the value of n is, both for here, down here, in the denominator of this fraction, r over n, and n times t. And again, same problem you're going to run into here with this n times t. If you don't put that in parentheses, you will get the wrong answer. So let's see how to punch this down here into our calculator, because that's really the biggest problem. I think you could figure out what numbers go in there, but getting it in the calculator correctly is a common mistake. So I'm going to go ahead and type in 330. And then I guess I could just go directly to the parentheses. I think it allows me to. We'll try it. 1 plus, and then I'll do 0.032 divided by 12. Now you'll notice here I don't put the 0.032 divided by 12 in parentheses. The reason why is because when I'm doing 1 plus those guys, the calculator obeys order of operations, PEMDAS, and so it will know to do this before adding to the 1. And then we're going to use a parentheses here to raise all of that to a power. So I'm going to go ahead and say to the power of, which is below the pi key. And now that for the n and the t, instead of doing it like you see here in the example, I'm going to go ahead and use parentheses at the beginning of the 12, and then times 13, no other parentheses until after the 13. If you've been having a problem getting these answers right, oops, sorry, I accidentally hit a couple of keys there. If you've been having a problem getting the correct answer to these problems, this could be very well the reason why. I'm going to go ahead and hit enter, and I get 499, and you'll notice that is the correct result. I strongly recommend that you go back through these review problems and you try them all yourself and make sure that you can get the correct answer for these problems. All right, I'm going to go ahead and say goodbye to this, and let's take a look at another problem. We are going to look at a couple problems that involve logarithms for solving, and I got to be honest with you. If you find these problems too challenging, I recommend that you don't spend a lot of time practicing them. What I recommend is you make darn sure that you can get every other kind of problem correct, okay? But for those of you who want to shoot for the stars and get an A, I'll show you how to do the logarithm problems. So here we go. So in this problem, in order to solve it, we got to get the x by itself. And that means first get rid of the 75, and we can do that by dividing. So let me go ahead and show you. And even though in the past I showed you a slightly different way to solve this, I'm going to show you how to solve this using the delta x method. So we're going to divide both sides by 75. That gets us 3 to the power of x, and that will be equal to 375 divided by 75. And those wonderful people at Delta Math, they gave us two numbers that I believe they are evenly divisible. So 375 divided by 75, I think that divides evenly, and it does. That gets me 5. So this is really just 3 to the power of x equals 5. Now, unfortunately, that makes this less of a good example, so I think I'm just going to leave it as a fraction so that we can make sure we enter it in the calculator properly. The next thing we're going to do is we're going to take the log of both sides, and right now I'm giving you no explanation as why. All I can tell you is this, is that if you had x squared of equals 25, and you wanted to get the x all by itself, you would take the square root of the left side, and in order to make that legal, you also have to do the same thing to the other side, take the square root. Okay, so that's the idea. We're going to take the log of the one side, and so therefore we've got to take the log of the other side. And in this case, it'll be 375 over 75. Now, one might ask themselves, why do we take the log of both sides? What does that do? There's magic here. What happens is this the x magically can go out in front of the log 3. And so what happens is we begin to get the x all by itself, which has really kind of been the goal all along in all the algebra that we've studied, even since you were in like 7th or 8th grade. So anyways, so then we do this log of 375 over 75 again. And finally, to get x all by itself, we divide both sides by log 3. So we get x equals all of this over log 3. And again, the biggest problem you're going to have here is getting this far and then entering it in the calculator incorrectly. So I'm going to try to help you get this right. Here, we definitely need parentheses around the log and before we go to this fraction bar. Okay, so let's see what does that mean? What am I trying to say? I'm going to go ahead and let me go ahead and clear this on my calculator. I'm going to go ahead and enter this in my calculator now while I can see what I've written, and then I'll bring this over there in just a second. So log of 375 divided by 75, and then I will close the parentheses, and then I will divide by the next thing, which is log of 3. So now I'm going to try showing you this. And let me go ahead and exit my drawing. And so now we're going to go ahead and try to divide by log of 3. There we go. And you'll notice that I have to put the 375 divided by 75 in parentheses. And I have to do the closing parentheses after the 75, but not after the 375. It's really important. I'm just trying to do the log of 375 divided by 75, so those two things need to be in parentheses. Then divide by log of 3, and let's go ahead and hit enter. We get 1.46, and the good news is we just had the x by itself, so that's all we got to do. If it said 4x, I would then divide both sides by 4. So I would divide this number by 4. If it said x over 3, I would multiply both sides by 3. Let's say it said x over 7. I would multiply both sides by 7, and so I would take this number here and multiply by 7. All right, let's go ahead and check our answer and see what happened here. I'm going to show solution, and hopefully it looks a bit like what we came up with. Sure does. And remember, again, be careful about that rounding. 1.464 rounds to 1.46, and they did ask us for the nearest hundredth, which means 2 decimal places. So there's that. Let me go ahead and get rid of this and clear, and maybe we'll take a look at another one. Maybe there's one where, see how there's the x over 3? Let's go ahead and take a quick look at that one. So here we go. I'm going to go ahead and get my pen out, and we'll be finishing up pretty quick. I'm going to go ahead and divide both sides by 144. So this will be 2, or not. Oh, hold on. I did something with my hand. I wonder if I can undo that. I'm going to have to exit drawing and try to undo that. Okay, let's try this again. Sorry, guys, I'm having some technical difficulties. My hand rubbed on the thing I'm drawing on, and so it thinks I did like a pinching, or a pinch out. Okay, so this will be 2 to the power of x divided by 3, and that'll be equal to 16 over 144. And to save us some time, I'm not going to go through every step. You can see all the steps if you want to by going to show solution. But I want to make sure you guys are with me on this. So I'll get to the point where it's going to be x over 3. And that's going to be equal to log of 16 over 144. Let's make sure that we put that in parentheses. Okay, then divided by log of 2. And again, if you're not sure how I got all this, you can go look in Delta Math. It shows you how to do this. But I want to make sure that I get to explain what to do with this x over 3. Now that you've got x over 3 equals all this, just multiply both sides by 3. When you do that, the 3 over here cancels with the 3 over here, and that's the reason why we multiply both sides by 3. And then once you get all of this, once this turns out to be a number, then just multiply that number by 3. That's all. Okay, so just wanted to give you some quick tips. And by the way, I'm at 26 minutes in, so I think I'm just about done. Let me go ahead and stop with the drawing. And let me just check and see if there's any more problems I wanted to show you. So here's half-life and doubling. They don't show you the formula, but they do say it's half. So again, you're going to use this formula that you get to put on your index card. And again, this is a question that I do not recommend for everybody to try to solve. This one requires that you use logs. And there's only going to be 2 of these questions on the test. One related to this type of problem. And by the way, if one comes up with an E, I'm going to give you more than one chance. So if you have no idea how to do the problem with the E, just get it wrong and then take the second chance. And maybe I might even give you 3 attempts on that just to be safe. Let's see here. So let's go back to, so anyways, there will be this type of problem where you got to get the x all by itself, and you're basically being given the equation. And then there will be one of these where you have to take the words and know the formula, and then here you'll need to get the t all by itself. Again, if you do not understand how the solutions are working in Delta Math for these last 2 problems, focus your time and efforts on perfecting every other problem here. That will serve you well. Okay, guys, if you watched this whole thing, you are amazing. And you should pat yourself on the back because you are a good student and you really care, not just about your grade, but about understanding. And I love that. Thank you.